Okay, so this one's going to be a long one, so I just want to preview what I'm going to go over. So the first thing we're going to talk about is perfect squares. The next thing I'm going to do is we're actually going to go over how to simplify all of these different radicals. So if that's something that you need help with, it's going to be, towards the beginning of the video. And then next, the last thing I'm going to do, so if you need to fast forward to the end of the video, I am going to be solving quadratic equations, okay? So just as a preview, we are going to start on identifying what perfect squares are. So perfect squares are numbers that, again, form the area of a perfect square. So this, pretend, is a perfect square. And if the sides are 2, the area of this is going to be 4. Okay? In other words, when I take the square root of 4, it gives me an exact answer of 2. 2 squared is 4, therefore the square root of 4 is 2. Okay? My perfect squares would be 4, the square root of 9, which is 3, the square root of 16, 25, 36. All I'm doing in my head is 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7. This is a list you can create. 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, and 15 times 15. Okay, so these are my list of perfect squares that I ask you guys to have memorized, as well as for next year you should have these memorized. And again, when you type these into your calculator, it will come out an exact perfect answer. So if I asked you guys, hey, what's the square root of 25? You would type this into your calculator and you would tell me that's equivalent to 5. These are 2 representations for an equal value. Those 2 are equal to each other. The square root of 25 is the same thing as 5. Those are equal to each other. If I asked you what's the square root of 16, you would tell me that that is 4. If I asked for the square root of 20, that's when we start to get, wait a minute, Miss Botica, 20 is not on my list. And when I type in the square root of 20 in my calculator, it gives me some crazy big answer. And I know that you hate rounding, so what should I do? Well, when you want to simplify something, if this was asked to be simplified, you look for what's called a perfect square that goes into 20, okay? So what 2 numbers multiply to make 20? That's what I'm looking for. So 2 numbers that multiply to make 20 are 2 and 10. But if you look back at your list, 2 and 10 are not perfect squares. So we're not going to choose those. What 2 numbers multiply to make 20 and are also on your list of perfect squares? Well, 4 times 5 is 20, and 4 is on my list. 4 is a perfect square. I call them perfect children, and perfect children get to come out of the house. So if you type the square root of 4 into your calculator, it comes out as 2. If you type the square root of 5 in your calculator, you can see he's not perfect and therefore has to stay inside the house. Now, of course, to check your answer, if you type this entire problem, 2 root 5, into your calculator, it should come out as 4.472135955 because these values, again, are equal to each other. The square root of 20 is equal to 2 root 5. Those are the same. So below, I'm going to practice some other problems with you, and I'm going to go a little fast because you guys can pause the video. Okay, so simplifying the square root of 50. Again, I'm looking for a perfect child in 50. I should say, if you guys are bad at mental math, a way for you guys to do this. So let's say you guys were trying to simplify the square root of, 72. Okay, and you were like, well, how do I know a perfect square that goes into 72? If you feel like you're bad at that, this is what you would do. I'm going to take 72 and I'm going to place it where it would fall at about on this table. So 72 would fall about right there. So in my calculator, what I'm going to do is to break this 72 up, I would do 72 divided by 64. Okay, that doesn't work. And again, pause this, try it. 72 divided by 49. Nope. 72 divided by 36. Ding, ding, ding. 36 goes into 72 2 times. 36 is a perfect child. He comes out. 2 is not a perfect child. He stays inside. My final answer is 6 root 2. Okay, so that's how you would find what number goes into 72. So this is handy. These perfect squares are handy to have written down on a piece of paper so that when you're doing these problems, you can see where I'm getting these numbers. So 50 divided by 49 doesn't work, divided by 36 doesn't work, but 25 goes into 50 2 times. Therefore, my answer is 5 root 2. Okay, now we have a number on the outside. Let's ignore him for now. What goes into 96? So I'm looking back at my numbers. 96 divided by, what's my first one? 81. That doesn't work. 96 divided by 64. That doesn't work. 96 divided by 49. Let's see. Nope, that doesn't work. 96 divided by 36. Does that work? Nope. 96 divided by 25. Nope. 96 divided by 16. Yes. 96 is broken up into 16 times 6. Now again, your perfect child is the 16. So this turns into 2 times 4 times the square root of 6, which is actually 8 root 6. If you type this into your calculator and this into your calculator, they will give you guys equal decimals to each other. Okay, that's a way to check to see if you simplified your radical correctly. The square root of negative 12. Now again, when you have a negative in here, I'm not too sure how far you guys went into this, but the square root of negative 1 is equal to I, or the imaginary number. So before I did this problem, I would actually just take that negative out and put I root 12, and then I would go through and simplify this down. Now again, if you didn't do I, you can ignore what I'm saying, but the square root of 4 and the square root of 3, therefore this is I times 2 root 3, or how we like to write it is 2I root 3. Over here, again, simplifying the square root of 44, this ends up being 4 times 11. I also have the square root of a squared and the square root of b to the third. So I kind of separated this down into their own radical signs. The square root of 4 is perfect. He comes out at 2. Square root of 11 is not perfect, stays inside. The square root of a squared is a. This squared and square root sign cancel each other out. They're inverse operations, okay? Now the square root of b to the third is the same thing as the square root of b squared times b. One more b. You have 3 b's there. So again, you can cancel this squared with this out. And so what you would have is 1b on the outside, and you would have 1 left on the inside. A simple way of doing this is just to look for how many pairs you have. So you have 1 pair of a's right here. You have 1 pair of b's, but you'll have 1 pair left, 1 b left over inside that radical sign. Okay, that's kind of the simple way of looking at this. Now, of course, this answer looks very big and sloppy. So what we like to do is we like to write all the numbers or letters that are on the outside together, and then the things that are left on the inside, which is the 11 and the b together. Okay, for 5, to simplify a fraction in here, you cannot have a radical sign over the denominator. So whatever you need to do to get the denominator out, that's what you have to do. So I'm actually going to change this fraction. So this fraction, do you guys agree that this fraction is the same thing as this fraction? Okay, I hope you agree. This is the same fraction. All I did was I multiplied both of these by 5, and the reason I did that was to make this bottom number into a perfect child. Now, because the square root of 25 is perfect, 10 is not perfect, he stays in the house, but 25 is perfect, he comes out of 5. I cannot simplify this down farther because this guy is inside a radical sign and this guy is not. Therefore, we cannot divide them. And so I would just leave my answer like this. The square root of 10 cannot be simplified down farther. Over here, the square root of 11 over the square root of 11 over 4. Again, guys, 4 is already perfect. So when I simplify this down, okay, these two things are equal to each other. Therefore, the answer is just the square root of 11 over 2. whatever you can do to get the radical sign out of the bottom. And if it's already perfect, guess what? He gets to come out. Okay. 8, doing some adding. I cannot, this is just like terms, okay? So this is like saying x plus y plus z. I can't add these together. They're not like terms. So what I need to do is simplify this down. And again, I would love to go into this. The reason you can add 2x plus 5x is because you factor an x out, and this is what you're left with. So technically, this is the answer, which is the same thing as 7x, okay? That's why you can add like terms together. So if I'm looking at these radicals, I can't factor anything out. I can, however, simplify these. So 4 root 3, which is the same thing as 2 root 3, plus 9 times 3 is 27. The square root of 9 is perfect, so it's 3 root 3. And 32 is 16 times 2, which is the same thing as 4 root 2. Now, looking at all of these, I see that my first two have something in common, so I can actually factor that root 3 out and combine my like terms. In other words, I just add the coefficients, 5 root 3, and then, of course, I stick this guy back at the end, okay? So this is kind of like saying 2x plus 3x plus 4y. That's all, okay? We look at these radicals as different entities than each other. So, but again, I like to kind of show you guys the y. So what's actually happening when you're adding 2 root 3 plus 3 root 3, technically you're just factoring that root 3 out, and you're left with 2 plus 3. Therefore, it's root 3 times 5, or 5 root 3. So that's what's actually happening to get that number right there. 9, when you're multiplying radicals, you're allowed to multiply what's underneath that radical sign by what's underneath the radical sign. So this turns into 18. When you multiply over here, again, the 2 is on the outside, so you're only allowed to multiply that 3 times 3, which is 9. Now, of course, we can still simplify this down even farther. So this is 9 times 2, which is 3 root 2. I don't know why I put 3, plus 2 times, oh, he's already perfect, 2 times 3, so plus 6. Again, I cannot add these together. They are not like terms. This is like saying, what is 3x plus 6? You cannot combine those, okay? That concludes the simplifying radicals portion, so we're gonna move on to the solving quadratics. A quadratic is anything with the highest exponent of a 2. Okay, they usually are in the form ax squared plus bx plus c. Now there's 2 ways to solve a quadratic. You can factor, or you can use the quadratic formula. And I'm going to be doing both of those below. So I see, or you can solve it algebraically, I should say, because I gave you an example of each of these. Okay, so the first thing, and why I wanted to note this, is before you start to solve a quadratic, you have to identify how you want to solve this. So if I wanted to try and solve this number 1 algebraically, I couldn't. And that's because I have an x value. If I wanted to solve number 2 algebraically, I could, because there's no x value. There's no second value right here by itself. Okay? So I'm going to solve number 1 either with the quadratic formula or factoring. And in order to use the quad formula or factoring, I first have to make this equal to 0. So I'm going to bring this 16 over, and now we have x squared minus 10x plus 16 is equal to 0. I personally like factoring first, so I'm going to use the old guess, check method. And hopefully, again, you guys are getting really fast with this. Okay, so guess, check. So the first thing I do is what multiplies to make x squared? And that's going to be x times x. My next guess is what multiplies to make 16. And my guess is going to be, I don't know, what do we want to guess? 8 times 2. Okay, 8 times 2 is 16. Now for the checking method. So to check it, I know that these two multiply to make a positive 8x. These two multiply to make a positive 2x. And the checking part should start to be done in your head. Therefore, that adds to a positive 10x. That does not check. I need it to be a negative 10x. So I know that I'm close and that all I have to do is change these signs to minus signs. Now, this makes a negative 8x, a negative 2x, and therefore that's a negative 10x, and that checks, okay? So after I'm done with that, I take my factors of x minus 8, and I set them each equal to 0. I need to find those x-intercepts, okay? So for this one, if I solve it, I have x is equal to 8, and for this one, I have x is equal to 2. If you take those numbers and plug them in, they should work, okay? Number 2, again, I can solve this one algebraically. So this one's just asking me what two numbers multiply that are the same that multiply to make 4. 2 times 2, or negative 2 times negative 2. The way to kind of show your work with this one a lot of times is what you'll see people take a square root from both sides. Now the squared and the square root are inverse operations. You just have to remember, since the square root of 4 is 2, you have to remember that there should be two answers, both the positive 2 and the negative 2. And again, this is called solving algebraically. Okay, you're just doing inverse operations as you normally would. You can also solve this one by factoring if you wanted to. So you would set it equal to 0. It would be x squared minus 4 equals 0. And this is called the difference of two squares. So when you factor it down, you'd have x times x, positive 2 times negative 2, because you have a 0x as your middle term. And then you would set each of those equal to 0. And when you did that, you would get the same answer. Okay, so if you do like factoring, you can obviously factor to get the same answer, or you can solve this one algebraically. And the reason you can do that is because there's no b term, no middle term. Coming down here to number 3, again, I'm going to start by factoring. I just like to factor, and I'm really good and fast with factoring in my head because I've been practicing. So what multiplies to make 2x squared? I know that it's 2x times x. And then I come over here and I ask myself, what multiplies to make a negative 15? And I'm thinking it's negative 5 and positive 3. I have no idea. I'm literally trying this right now with you guys. So in my head, this is what I would do. Negative 5x combined with a positive 6x. Would that give me a 7x? And the answer is no. So negative 5 here and positive 3 here didn't work. So I would change it and put the negative 5 here and the positive 3 here. And when I'm checking this in your head, so check this in your head, positive 3, negative 10 gives me a negative 7. So let's go ahead and change those signs. Positive 5, negative 3. That's a negative 3, positive 10, which gives me a positive 7. Okay? So again, you should be doing these quickly in your head. Please practice these factoring problems. We're not finished yet. We're going to set each of the factors equal to 0 because these said solve, and that means they want us to find the x-intercepts. So add 3 to both sides and then divide by 2. You'll get x is 1.5 or 3 halves or 1.5, and with this one you should get x is negative 5. And again, if you take those numbers and plug them in for x here, you should get 0. Over here, number 4, I'm trying to factor. Oh, look, I can't factor this one. What? X times x. What multiplies to make 7? 7 and 1. None of those work. Oh, no. Just because I can't factor something doesn't mean there's not a solution. Now, I can try plugging it into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac. Homage to Mr. Jet, all over 2a. So once again, your a represents the number that is in front of your x value, and because there's nothing there, there is a 1 there. Your b represents the number that is in front of the x value. For the a, did I say x? I meant x squared. B is in front of the x, and c, see you later. See ya. He's all by himself. Okay, so we have our a value right here, and I'm going to replace this a value with my 1. And I have my b, which is 2, so I'm going to replace my b's with a 2. And then I have my c value, so I'm just going to replace my c value with my 7. Okay, so let's simplify this down. I look at this like 3 different entities to simplify down. I have this I need to simplify, I have all this under here, and I have this right here. So when I go to break this down, the negative 2 just stays a negative 2. The denominator, 2 times 1 is 2, plus or minus, and underneath the square root sign, let's do this. So 2 squared is 4, and 4 minus 4 times 1 times 7 is 28. 4 minus 28 is negative 24. Okay, now again, I know that taking the square root of a negative, I can't do anything with the square root of a negative, but I can take out that I, that imaginary number. So I'm going to go ahead and take that out. So negative 2 plus or minus I times the square root of 24 over 2. And I also noticed that the square root of 24 can be broken down. And the square root of 24 is 4 times 6. And negative 2 plus or minus, the square root of 4 is 2. And the 6 stays inside over 2. And because on all 3 of those that I simplified, because you have a 2 here, a 2 here, and a 2 here, you can actually factor that 2 out or divide that 2 out. So you would have negative 1 plus or minus 1I root 6 over 1. And I don't have to put over 1. So this is the most simple answer for solving this quadratic.